All right, this is the last thing we're going to do. Um, I hope you've been working on your final review. It's going to be very important that you do that. Um, we're going to look at Pascal's triangle today and the binomial expansion, the binomial theorem. It's very interesting. I've posted the notes, and these are how we will fill them in. So you'll have the filled in notes. You'll also have these so you can see how it's done, but it's very easy, honestly. Blaise Pascal is famous for this triangle right here, and it goes on forever. It's infinite. And it also, the Fibonacci sequence is involved in it. It's very, very interesting. Um, but all the numbers on the outside are ones. So I'm going to go ahead and fill those in. Okay? And each number, each box under the previous numbers are added together. So this number here is 1 plus 2, which is 3. 2 plus 1, which is 3. 1 plus 3 is 4. 3 plus 3 is 6. 4, 5, 10, 10, 5, 6, 15, 20, 15, 6. Now you'll notice there definitely is a pattern. You can see the patterns develop, whether it's even or odd. Okay, these are odd patterns here. They have an odd number of components, or factors really, is what it's going to boil down to here in a second. So you can easily tell. Now, do we have to memorize all these? Well, for right now, you almost have to write them all out. But we're not going to go that far. Now, what does this mean? What does this do for us? I'm going to be referring to both up here and down here. Okay? Well, up here is the triangle. But here's one way it can be used, and it's very interesting, called the binomial expansion. Now, if you think about it then, if we take a binomial, like a plus b, x plus 1, doesn't matter what it is, if we take it to the 0 power, anything to the 0 power is 1. Well, look at the top of our triangle. 1. Okay? What is a plus b to the first? Well, then it's just a plus b, right? Which is 1a plus 1b. Okay? 1, 1. All right. What's a plus b squared? Well, a plus b squared is a plus b times a plus b. And if we FOIL that, we end up with 1a squared plus 2ab plus 1b squared. That's cool. 1, 2, 1. Look at the third line. 1, 2, 1. All right. A plus b cubed. Well, a plus b quantity cubed is a plus b times a plus b times a plus b. We'd have to FOIL it and work it all out, but we don't have to. Because by knowing the binomial expansion, we know that they're going to be 1, 3, 3, 1 in front of them. Look at that. 1, 3, 3, 1. And look at how the exponents decrease with the first term, and in the second term they increase by 1. Is that cool or what? Now you're asking, where's the b here? Well, it's b to the 0. B to the first, b to the second, b to the third. A to the third, a to the second, a to the first, a to the 0. Because anything to the 0 power is 1. We just don't write it. And some of the examples, I will be writing them. Okay? So let's do the a plus b to the fourth expansion. Well, that's going to be, what was this one? 1, 3, 3, 1. So this is 1, 4, 6, 4, 1. Hold on, Mr. Thamer. How'd you have that? Did you have that memorized? No, I just know the outsides are 1s, always. And I know that these two are going to be 1 plus 3. And I know this one's going to be 3 plus 3. Or if we go back to the Pascal's triangle, I can cheat and look at that instead. That's not really cheating though. That's mathematical. Okay, so here's your terms then. A to the fourth, a cubed, a squared, a to the first, a to the 0, b to the 0, b to the first, b to the second, b to the third, b to the fourth. Now you're asking, how does this work? Well, it just means if we took a plus b times itself 4 times, this is what we are going to get. So if we take a plus b to the 5th power, what is this expansion going to be? Well, I know the outside's a 1. I know it's going to be a to the 5th, and I know it's going to be b to the 0. Now I know b to the 0 is 1. I get that.